Welcome to PyOhio 2015. In this talk, we have Tom Ballinger, who will be talking about REPL-driven development.
Exactly why. Great. Hi, everybody. Got a bit of a cold open, so we'll go right in. So if I'm here at the REPL, right, I'm typing out Python, hello.py, Python works in both of these ways, right? I can run a command, but I can also type Python and just hit enter. Just a second while I live code, take a drink here. And then, right, we can run expressions, right? We can do all sorts of things here. And there's a lot of introspective sorts of things that we want to be able to do. Here I imported this module that we could have just run directly. We're looking at it. dir tells us attributes on it. We're looking at this function thing here. I hit Control-L to move us to the top of the screen there so we can see in the back. Looks like it's a self-promotional function, basically, saying that my name's Tom Ballinger and that the website and an email address. So I think this is important to... This talk is it's a bit of a misnomer. It's REPL-driven development, but it's mostly like you should use a REPL more. So the first 10 minutes are going to be, let's use a REPL more. Here we're writing a function. We can also write functions in our REPLs. They're not great text editors, right? This is not the place to write novels. This is not the place to write big software, but you can write little things like this. Turns out in Python, functions are objects. So we could look at the type here, and we could hold on to that type, and then we could look at the help for it, which is what we're going to do in a sec. And then we could learn about how Python works, which I think the REPL is one of the best ways to do this, to just play with it. It's like this function class, how does this work? Looks like you put in these kind of 2 or 3 arguments, and then you can build a function. So maybe let's try to do that. We could build a little handcrafted artisanal function all by ourselves here. The first argument was a code thing. So let's look at one of those code objects looks like. You can get it on the function object. I hit Control-L there again, right? I'm using Control-E and Control-A to jump to the end and beginning of the line while I edit these things. All right, this looks like quite a constructor, 11 arguments. Let's not try to use that one. I happened, though, to be experimenting and looking around earlier, and I tried dir on built-ins. And I was just exploring, like finding out what we can do in Python. And I found this one called compile. And now I'm going to try help on compile, and it looks more reasonable. It just takes 3 things. So we're playing around. We'll be able to like put in those 3 things. The first one was source. So we're going to try to use build that string that will be our source here. And this is going to be kind of hard because I'm trying to use quotes inside of quotes. I always get confused when I do something like that. So I'm going to give up here, right, because this isn't going to work. We have to do double quotes or something. When you're in a REPL, there are different ways that we can represent strings or really any object, and we're going to use strings as an example here. I'm saying s equals this thing. It's probably not quite going to work because we're going to wrong. This isn't code yet, so we're going to put in the double quotes. But if we're trying to figure out exactly how a string like this works or any kind of object, in the REPL we have the stir representation and the repr representation of this. We're going to look at both of them. The difference for strings is there are going to be quotes on the outside. So here we're going to, in just a second, look at what the string looks like if you just do it all by itself and what it looks like if you say, I want the programmer-friendly version of this. So here's the stir. It's like the displayed version. Here's the repr. When you type print and then an object, you automatically get the stir of it. And when you just write it in the repr, or in the REPL, you get the repr version of it. All right, so this will probably work. We've got our string here. Now we're going to try to build that code object. And I forget how that works again. So maybe let's go look at the help again and remind ourselves, how did that work? What was it? Oh, right, it was file name. There's a second thing. Got it, the string first. So we'll try that. Oops, I'm still typing here. Type. Great, so we're going to build this code object. See how it goes. I'm going to remind myself, how does that function constructor work? I'm not used to that. Normally I use def to build my functions. But we're going to put the code object, and then it said we needed a dictionary, and globals will return that globals dictionary. So we've got our function. I didn't save it to anything, so I'm using an underscore here to say, give me that last expression that I evaluated, and let's store it in that f variable. And now we're going to call it moment of truth. It worked. Great. We can build functions like this. So the point, obviously, is not that you can build functions like this, because you shouldn't do that. Here's a problem with it. So inspect is another great module that lets you see information about objects. Here we're going to find the source code for this function, or first for inspect.getSource to see how it works. This is the repr. That wasn't very useful. Let's print it instead. Great. So you can, while you're in the REPL, get the source code of lots of functions you might use. So let's try that with our artisanal function, and it didn't work because we didn't quite set up. We never wrote this to a file. It didn't know where to find it. So this is, how about, so far, who's learned something about the REPL yet? There's a function you didn't know or a thing somewhere. I mean, yeah, it can be great to watch people do this, but I think it's really fun to be, to be there just typing stuff. However, I think it's a more enjoyable experience when you're not using the default one. So next we're going to look at sort of similar thing, but we're going to use bpython, which is this really fun, exciting tool that I happen to work on, so I'm kind of self-promoting it here. You can see we have tab completion on our imports. We're going to have tab completion on the attributes of that module object. Now we can say, oh, I want to dig into that thing, and we're doing things in less steps because I didn't have to call help, I didn't have to call dir, and then on the next line find it. We're just doing it immediately. This is the bytecode of that function. If we want to understand it, there's this cool tool called dis that lets us disassemble that. This is sort of readable. You can kind of understand what this function does, right? It builds this constant, and then it prints it, and then it prints a new line. We haven't, or I guess we did see the source a while ago, but it was sort of reasonable. I'm undoing here. That's huge, right? That space that we were using up that was in the way, we've reclaimed that space, which is kind of nice. We're just going to keep doing the same kinds of things. The big lesson here, I think, is, we'll get to this later, but don't use the normal interactive interpreter if you're not trying to debug a problem with another interpreter. I think you should be using IPython, or you should be using bpython, or there's one called pt-python, just because these are great. We're doing the same kind of stuff here. We've got this gray, if you can see it, there's some auto-completion that's based on history here, which is kind of nice. Because these docs are popping up here, I don't have to refer back and call that help function, call a dir function to see how these things work. I've got this artisanal function again. Let's see if it works. I forgot to store it in a variable again. I'm using that underscore trick here. Let's call it, see if it works. It works, that's great. Now I could hit F7 in bpython to take this session and throw it in a text editor, and then go back and modify that function that we built, and then we're going to rerun the session, and we're going to be back in the REPL. So this is a nice way to be plugging along in the REPL, jump out to edit some earlier history, and now we're back here, and it's rerun it the new way. So just one of the tools that's nice to have when you're in a REPL session. Paste bin is an option. You can copy what you've got to the clipboard, and then if you hit F1, it'll show you all the different keys that there's some discoverability here. Now, I think bpython's great, but the big message here is maybe don't just type Python, because it's quicker to be using IPython or bpython or something. And here discoverability is pretty fun, right? I'm never going to sit down and just read all the docs for a string class, but I might sit here and tab complete through them. And it's kind of fun to find out, like, oh, did you know that this one? Here's how it works. I think this passive discoverability is really important when you're discovering a language or exploring a language, and you don't have the discipline to sit down and read, the 600-page Python book. It's nice to be passively like, oh, I found out about this thing, about that thing, because I had the object and I looked at the tab completion on it. All right, so that was a cold open. Now I'm going to actually say hello. Hi, I'm Tom. This is, I said, a little bit poorly misnamed talk. When I think of REPL-driven development, I don't quite think of just being in a REPL doing things, and this is more an advocation of be in a REPL, do things in that REPL. So use the REPL more. That's number one. Number two is don't use the default interactive interpreter. When you're debugging something, you often have to. You say, hey, I had this weird problem in IPython, and then the thing you should go do is back the default interpreter, because they are complicated things. You have to keep track of them. They're not real Python kind of, but I think it's worth it for that discoverability you gain. Okay, some disclaimers for this talk. I'm going to talk about REPL-driven development I'm going to talk about it in Lisps, and I don't really use a Lisp very much. I'm going to talk about Emacs a bit, and I almost never use Emacs. I, last week, emailed some of the organizers and said, hey, I don't think this talk is really ready. Could I give this other one that I've given before? And they said, you know what, PyOhio is a really friendly conference. Just give this one, it'll be fine. So we're going to have extra time for questions. I would love to talk about these things. I work at a programming retreat where we do a lot of programming in the REPL, and so I have thoughts on this stuff, but I haven't fully formed parts of it. So we're going to have extra time for questions in a bit. And then finally, as we said, REPL-driven development. This isn't, I think it's something a little bit different, but this is just advocacy for the REPL in general. Cool, so what is the REPL? That's a little mean. Who feels really confident about, they know what, when they hear REPL, that's fine. They know what we're talking about. Great. See, that's clever. I phrased the question so that we did, instead of asking who didn't know. I think more people should do that. So read, if we're going for the Python definitions, we're getting text from the user, then we're evaluating it. Maybe you're calling exec on it or something. We're printing out the output of that exec, and then we're looping. And you can make arguments and say, well, read, we're really not talking about the Lisp read, where this read comes from. That's where you parse a string into kind of the data structure that it would be in. And then the evaluate, if you have statements and things too, maybe it's a little bit different, because in Python we need to say exec instead of eval. There's some, but when I say REPL, I really mean interactive interpreter. I mean a thing that gives you that immediate feedback, and I mean just having an interpreter that we can get code into somehow, even if we're not typing it. What's a REPL good for? I really want to push this one of understanding the language. If you're writing some code and you're 95% sure that operator precedence is going to work the way you think it will, or that the return type of that function is such and such a thing, I think 95% sure is unsure enough that it would probably save you time if you just check that in a REPL. You could write a little test script, right, the same thing, and print the result, but I think it's really powerful to be able to say, oh, I'm not sure how this works, but I can find out in about 7 seconds. I can jump over to my REPL, type in a simple expression, and oh, okay, precedence does work the way I thought it did. Exploring a new library, you see examples and documentation a lot, maybe too much, of interactive interpreter sessions. So I import the library, and I do this thing, and it has the result, and I do this thing, and it has the result. And I kind of like that for documentation, but I've heard arguments where like, oh, that's not how you use it in real code. That's maybe not so great. But when you're the one typing it, I think it's tremendously powerful to be able to start playing with the library. Yes, you really ought to read the docs. It might not all be there in the doc strings that you could get from help, but you can learn a lot about how this thing works, what these objects do. It's fun when you think of a library. It's like, oh, the requests library. This is a library that gives me new superpowers in the REPL. And I can find out what those superpowers are by importing this thing, by building the different objects, by banging at them and see what they do. Exploring environment. So this is when you're in a debugger and you got to the site of your bug and you're trying to figure out, looking around the environment, seeing how it works. People do this a lot with their web apps. There's like the Django shell. Is it called Django admin shell now? So you can open up. You can say, all right, please load up all these things for me and let me just play around here. Maybe I'm doing real work. Maybe I should have written a script for it, but I didn't. And I'm doing this live on the prod server. But I can look around. I can change things, change models. I can, this is a neat programmer interface. It's not a good user interface generally, but it's a powerful user interface. And I think we should spend more time there, and we should spend time, the time we spend there should inform how we build our APIs, how we build our libraries, how we build our objects. It's like, maybe if this were useful at a REPL. That's a superpowers bit. Some benefits, the fast feedback I think is huge, of being able to type something, hit enter, and see it immediately, and see every intermediate step. I discourage typing long lines at the REPL because the idea is that you see each intermediate step. You see, oh, okay, there's where the problem was. Instead of a complicated one-liner where the result of this expression is passed into this expression, is passed into this one, you see each step there. And we did some of that with not actually assigning the variables right away, but typing an expression and then grabbing it if it's what I wanted. Doc test. Who's I don't want to look for complaints about it yet. So who has used doc test before? So I think this is, without any hands, I think it's underused. It's not a great test. You don't want to be using it as the way that you write your tests. But it's this, it is this thing where you could basically copy and paste a REPL session and into your code, and now that code will be run when you run your tests. Often it's called doc tests because in your docs you might have greater than space some Python thing and then show what the result is down below. And this keeps your docs up to date, but you can use it sort of for describing your API in the first place. Let's look at that real quick. So this is what doc tests look like. Maybe you can, in your module doc string, you could put some doc tests. I think it's nice for defining the interface in the first place. You're saying like, oh, you know what? I probably should have some kind of have message, and it should look like this. This is what happens when you do this to it. This is what happens in these cases. You can write this out first, or you can just do this in a REPL as a thought experiment. Like, I wish I had a thing that worked like this, and then go implement it. And you can also do it in your, let's find one that's in a method or something. So you can also do the inside methods like this. Now, these don't, it's just a terrible testing framework because it's just checking that the string that we got when we did this looks like this. So we're losing all our power of mocks, all our power of these nice assert statements. But it can be nice because you can get regression tests for free. Say you just play with something in a REPL and paste it in. It can be nice for describing to users what this looks like. The TDD thing I think we've touched on already with if you design your code such that you could imagine it being useful to you in an interactive session, then you're doing some of the same things that test-driven development would make you do, which is like, oh, would I be able to test this independently? Would this be useful? And then here I have that, would they be useful to themselves versus dependency injection? So to make things testable, maybe you want to have them take more arguments, so they're not doing things with concrete objects themselves, but maybe you want the convenience method that does the common thing, and that's the thing that would give you superpowers in the REPL. And I think you want both of these. You want the simple version, and you want all the parts included, kind of like the way the requests library has the common stuff, and then all the interworking, complicated parts that are sort of inside of it. These are just a few examples of things that maybe you might be a little confused by. What's going to happen here? Is our final dictionary going to say, is it going to be 1 mapped to 2 or 2 mapped to 1? Who knows? You'll have to try it yourself to find out. From Brandon Rhodes' talk yesterday, the precedence here, is this going to work the way we expect? If I'm asking, it probably doesn't. But why? You'll have to try it to find out. There's a fun Python quiz by Reed Barton online. Basically, this doesn't do what you think it might, but you have to try it to find out. I don't want to teach you these things. I want to say, when you see a puzzle like this, your first instinct should be, ooh, I could find out. I can get a piece of evidence, get one data point with which I can continue to build my mental model about how Python works. Okay, where do we use REPLs? A way that I commonly encounter one is that I'm using a debugger, and I get to the spot where I think the bug is, and then I want to look around that environment. And the debugger has nice tools for this, but I'm more comfortable in a REPL. So let's go to that one. PUDB is a debugger that I kind of like. It's a lot like PDB, the same key bindings, except it's graphical, and I like kind of terminal things. So we're jumping around here. We can get in here, step into these. We can jump to these different scopes. That's all well and good. But we can jump in a REPL in a certain environment. So in here, inside of ddent, I'm going to open a REPL with bang. And then here we are in bpython. I can say dir, and look at this stuff. And then I can start playing with the objects the same way we were before. So even if someone's code doesn't have objects that are easy to import in isolation, at least we can look at them in the running code. The Flask debugger, so sometimes you have web interfaces that will, in debug mode, and we've got to be careful with this, of course, will bring up a REPL, and you can explore what happened at the traceback. IPython does this too. You can, at any point when it threw up an exception, say, oh, could you start a debugger or a shell at that point where the exception was raised? The Django admin shell, this is the superpowers one. It's like, oh, it's not great, and now you're not code reviewing that migration that you wanted to run, but you can, these can give you superpowers, and when you're building the library in the first place, it's nice to think about how can this thing that I'm making kind of be useful to a user, and sometimes it's easier to imagine a immediate user, a programmer sitting at the interactive interpreter than it is to imagine a coder that's using this library deep in some other libraries later. Manhole is this nice library that lets you jump inside. It kind of freezes everything, all the threads, and lets you jump inside, look around what's going on there. Just anytime you have in a session, a environment in Python, a nice way to look around it is with an interactive session. IPython, which we'll talk about more later, but it's a big one. It's important. So what is REPL-driven development? I think this talk, I gave it a nice drag people in name. What I think of REPL-driven development is doing things from your editor and running that code. And this is something that's big if you're Emacs and you're using Slime and some Lispy language. You do a lot of this. You're writing code, and then you select some of it, and you spit it out into a REPL. Maybe it's one you can see, and you copied and pasted it. Or maybe you can't see it, and it just runs it, and then spits back the result. So let's look real quick at one of those. Whoops. So I've got some program over here, and I want to see how this expression works. And I pop over here and actually run it. Now, there's a lot better tooling for this than we've got here. And I come over here. I want to run this one. Whoops. And then I can go look at those fragments and see how that worked. What's the len of this one? Oh, OK. Fragments, not keys, 0. First one. That's not how that works. But I guess we could listify that. Nope. Oh, it's a set. That's why. We'll ignore it for now. It doesn't even have keys. I can undo these. But this idea of being in your editor, which is really good at writing code, right? Unlike this REPL, and then having those objects live somehow. And I'm not going to go into that much because I think the paradigm that makes more sense to many of us, or that's becoming very common, is, all right, we'll describe these first, right? Run this code, and show me the output, run it in a real REPL that I can see, or just a daemon that's running, run all the code in this file up to this point. But what you end up with is kind of this ball of state. You're like, oh, run this code, now run this code, now then run this code. Not in a separate session, but in the same session. And managing this ball of state is a separate thought process you need to be having. You have to be thinking about, okay, I ran this code here, and I ran this code, but I forgot to run this. Or when I set the constant at the top of my file, I've only evaluated that once, and then I changed it, and then I tried to run this function down here, but I didn't reevaluate that new constant, and so I'm running on old code. So it's this extra thing you have to keep track of, and that's the thing I want people to be aware of about this process. And I think most of us, we see this a lot with IPython. So I'm going to run this a equals 1. I'm going to run b equals 5. Now the value of b is this. And then I go back here and change this, b equals 3, but it still says b equals 5 here. Or I could have b equals 10, but b is not going to be that. So keeping this model straight of, and IPython helps us with these little in 5, in 8, in 9. But you need to imagine somewhere there's a real session where you had each of those inputs. And this would make sense, but this doesn't necessarily make sense because these can be out of whack. And as it gets more complicated, there's temptation to change some code. That one works, but we weren't using a new version of that because you didn't redefine this function. So a thing to be careful about. Oops. Great, and now I want to break briefly for questions because the rest of this talk is about reloading, which is sort of a different topic. You should actually feel welcome to leave after this. But I wanted to ask, just talk about REPLs, see if you have any questions that we could talk about. The last 10 minutes of this or so are going to be about reloading and how terrible it is and how complicated it is. So if you have a question about how to reload modules in your REPL session, maybe that could wait. But anything else I think would be great to talk about now while this is still fresh. So questions, anybody? Yeah.
Could you talk a little bit more about bpython?
Sure. I'd love to talk about bpython. It's this interactive interpreter similar to IPython, where it's in the terminal. It should be a pretty similar to the normal interactive interpreter. The work that I've done on it was basically rewriting the front end so that these variable bindings finally really got undone. But also, you can kind of pop in and out of it without it taking over the screen, because it used to take over the screen. The reason that I started using it before I started to contribute a bit to it was that for live coding, which I do a lot of at work, at this programmer retreat where I work, that undo was really powerful. Being able to have only 10 lines on screen, get some information about an object, but then be able to jump back. And then also this kind of history that we added later where, I can get the last time I ran this. Those were some features that were useful for live coding. And so I think there's maybe a sweet spot of that for bpython. And if you're not live coding, which is an interesting thing all by itself, it's like maybe nobody should be live coding ever. But if you're live coding, I found it a helpful thing. And then I really like the tab completion that's kind of in your face. That's all. Sorry, is there anything else that you were curious about? Okay, cool.
Just a quick question about the differences between bpython and IPython.
Mm-hmm.
Could you highlight a couple points about bpython that you prefer over IPython?
Sure. So IPython has about 100 things bpython doesn't have, and it's better, basically. But there are about 3 things that bpython has. I've mentioned this already. The big one for me is undo, because not only am I managing my Python namespace and my environment there, I'm also managing my screen real estate. And so it's been helpful for me, which is some of what IPython does for you, too. What else? So we don't have any magics. Instead of these things, we use keys. And then we ran out of F keys, and there are no more features. So it's a less featureful kind of thing. So one other thing that I kind of like, which again, IPython absolutely gives you, is this throwing it into an editor, modifying things, and then rerunning them. And the only other thing is the tab completion here, which we have on a variety of things. And I have found this really is helpful, particularly for people not yet comfortable with hitting tab all the time for tab complete. Like that's what most of us probably do if we're in IPython, because you want to have your tab completion for variable names. You want to have your tab completion for what methods it does. You want to use question mark method name in order to get the documentation about something. This is nice because it pops up immediately. So if there's someone that's kind of new to Python, or particularly new to Unix kind of, or sort of programming, I think it's nice to hand them bpython. But generally for a useful tool, we'll talk about this a bit, but if you're doing like a bunch of stuff and that stuff takes time, undo is no longer useful to you because it takes a second to undo now. So as soon as you're doing useful things, this sort of falls apart. So I think of it as a sort of a teaching tool, as a tool that I use when I'm checking syntax, because that's a lot of what I do with a REPL. And then if you're doing large data set stuff, this is probably not a tool that you want to be using. All right.
So out of curiosity, how do you run files in bpython? I use IPython's %run.
Yes. Okay, we're going to talk a little bit about that, but you don't. So %run, we'll talk about it a little bit, but in IPython is a way to have existing state. You have some variables and things, and then I want to run this file in its own namespace, but then slap that namespace into my current one. Mm-hmm. And this is a really useful way to kind of iterate on a module. It can be a little bit deceiving because you're just slapping that namespace into your current one, and you may have, if you got rid of some variables in that file versus the last time you ran it, things may have disappeared. There are some possible issues with it, but run is really useful, and we don't have a run. We have some different things that I actually can talk about now. Generally, if you're changing something, we're going to rerun the whole session. So if at the top here, if we import some custom thing, and then we go make changes to it, and we use it here, then you're going to hit F6 to do a kind of a hard reload of the whole thing, which will reload that and redo this stuff here. I think it's a little bit more trustworthy. You still have to abandon this fancy thing to the normal Python interpreter when you have a problem. But it's really useful to be using run because that doesn't re-execute all your things. Yeah. So in bpython, because kind of the undo is sort of part of it, the way that you run things is you rerun the whole session. Fortunately, you don't have to restart bpython for this. You have the same things and the same commands, but you have to rerun it. There's a big difference.
When you hit undo, do you get rid of the variables as you are undoing?
You do, for the most part. Yeah, so, yep, we've got A and B here, and then when I come up here, now there's no more B. But there's some stuff that's still global, so sys.a equals 1, import sys.a is still there. So you have to do kind of this harder reload thing where you hit F6, and that goes through sys.modules and deletes a bunch of stuff, but sys is not in that list. Sys is still going to be there. So you can't trust these reload things. That's going to be our moral for the second part, but I would just never trust if it's the Flask auto reload, any kind of reloading thing, I wouldn't trust it. You have to have kind of understand how it works to reason about it, and usually it's faster to restart everything and get the reloading part out of the equation.
Hi. I was wondering if you had any tips or tricks on kind of managing the ball of state, as you called it, which I thought was really
Sure.
good. Because I used to do a lot of interpretive stuff through IPython notebooks and switched back into just doing like straight scripts because I could manage, okay, this happens and that happens and that happens, and not go, this happens and, oh, wait, where's my data?
Sure, yeah. That's when I use bpython kind of for that. It's very limiting and that we can't do that, but because we can't do it, we can't get in that situation as badly. And I would retreat to files at that point. It's like, okay, it really is, we'll look at this in a sec, but in IPython, I will do, kill kernel, just hit it a lot. There's a pull request where people have said like, hey, don't you think we should maybe add, shouldn't there be a reset and run all in IPython? And like, yeah, there absolutely should. I think they don't want to train you to just hit it all the time because that could take a long time if you're really redoing all this stuff. But I think that's the answer. You have to be reset and run all. And down here they have some recipes for like making a button for it or making a keyboard shortcut for that. Because I think that's what you need to be doing all the time. But that can be frustrating if you had stuff that took time. So I would say do things that don't take any time. So don't do any real work. And then you'll be fine because you can just redo your whole thing every time.
What was the name of the program that you used that ran through your code at the very beginning of the presentation?
Maybe PUDB, possibly. Was it?
Yeah, like the automated typer. When you were away from the keyboard.
That was a QuickTime video.
Oh, okay.
I've tried a lot of solutions there. One that I really like is ASCII Cinema, which is great for this. But for this today, that all I could figure out that would really work, that I could really trust, was a video. Didn't need a network connection. There are other things out there, but that was a video. Yeah. Is that maybe good for now? All right. So we have just 10 minutes of content, and we can talk more after that. Thanks for dealing questions. Appreciate it. All right, what about real software? What about when you're not doing these little scripts that are admittedly most of what I write, since I am not at a company that is building a large piece of software? Often you have to reload things. You have modules, maybe you have modules that depend on other modules, and you're modifying one or both of those. Well, there's reload, right? There's this function in Python 2 in the global namespace called reload, and you don't give it a string like import, you give it an object, and it goes and refreshes that object. But if you did from that module import something else, that other thing's not going to get updated. You have to be careful with this reload. Does that make sense? I see some puzzled faces. In here, let's just Python to prove it. Import sys. This won't work because I can't modify sys. Import, look at this test thing, a equals 1. Import test. And then if I were to say, if I say from test import A, and I say reload, I'm not going to prove it because I'd have to go back and edit it again. But if I say reload test here, sure, that reloads test, but it doesn't update the A variable. That'll be whatever it was. So it's one thing to be careful of. A question I asked about 6 years ago, this is my first Stack Overflow question, I think, was, I'm looking at this code, what could this possibly mean? Why do they import these things and then immediately reload them? What sense could that make? Does anyone know why someone might do that? You probably know, and you're thinking it in your heads, but the answer was, well, that way if you reload the top level one, reloads of those other modules will be triggered, right? So if I reload whatever module this is, that will also reload nerd and SM and tensepp and all these things. So you could write your code like that, but that would be terrible. There are some clever things that are used to try to figure out what you've imported and be careful with them. One of them is IPython's deep reload. We won't look at using it, but it's here, this lib deep reload. I haven't been able to break it much. I haven't been able to break it at all, I should say. It seems to do what we want. It's not going to catch those from module import function, from module import constant problems, but it is really going to reload all those things. Next we have IPython's auto reload. So maybe you don't want to have to actually know which module you updated and then reload that. And maybe it's several, and maybe you would like it to kind of carefully go through. This auto reload thing in IPython will, here we are. Every time you run a line of code, it'll try to import everything. I'm not sure if it's doing some caching to like prove, oh no, this one hasn't been modified, but I think it will just reload everything. This works all right. It does some interesting magic where if you've said from module import function, that function will be updated because this thing kind of goes through those modules, replaces functions with a little wrapper thing, so it still looks like a function, but they can keep a census of them, and that way they can swap out the real function. So it's doing magic things, which means we can't trust it, basically. But it seems to work well for people that, if you know what it's doing, it can be really useful. Again, as soon as you have a problem, you probably put away IPython and you bring out Python, or you put stuff in a file and try to get it to work. This is a common refrain on #Python, the Python IRC channel. A lot of times it's like, hey, this thing isn't working. It's like, great, before that's interesting. We're not IPython experts. You should use Python to run this first. So I do that doubly so with bpython because I know how buggy it is. So if you have a problem, I think it's worth it to use those cool REPLs, but then you have to go back to it. So suggestion 3 is don't trust any kind of reloading at all. They're really useful, and as soon as you have a problem, I think you have to throw them out. Unless you wrote it and you can have confidence in it, you've really read the docs about how it works. But if it's magic to you, then I see this in Flask a lot with auto reloaders. It's like, oh, it didn't quite work, or you don't have a good model of when it does and doesn't work, then the first thing you check needs to be that, which can be frustrating because every time you have a bug, you try that first and it doesn't help. But I think it's a thing to be not trustworthy of. So there's this interesting idea dealing with this ball of state thing. In some languages, this is how it goes. I don't know Smalltalk, so I can't really say things about it, but people say, like, in Smalltalk, you just have this image, and you bang on it for a while and just save the image. And so I don't know if that's true, because I've not done Smalltalk things, but I know that's true in R. You can save the session, and it's not going to save a history of the commands. You won't necessarily ever be able to reproduce the state that things are in here, but it's this live system that you can serialize, and you can reify, and then keep doing stuff with. And maybe that's okay, but that's the situation that the ball of state thing puts you in, and in Python we don't have great support for take this environment, save it to disk, and restore it later. So IPython notebooks usually, they can save the output, but usually you're going to rerun it, so you want to make sure it's reproducible. So some of the solutions, the %run, the run magic in IPython is pretty good. You want to have that mental model for what it's doing is running it, executing the module, and then taking that namespace and slapping it over your current one, which works pretty well. There could be cases where, you have this variable still defined here that wasn't deleted because you thought it would be there. Execfile is different. It really runs it in the current namespace. So if it's trying to read variables, it can read things from your current namespace. It shouldn't be a problem if you were assigning values to all those variables in the module, but you could, something could run correctly when it shouldn't have, say. And then I or B or just Python-I is really useful. This is a way to run that module and then kind of stay in that namespace. Or I don't know whether it kind of does it separately in the module and slaps it in the namespace, but there's not much difference because there's no prior state. So anytime you want, you can say Python space -I space your module, and you will be as though you're inside of that module namespace. And this is a nice way to work on these, but it doesn't get rid of that problem of, oh no, I had some scaffolding code that I wanted to keep between different runs of this, you have to put that scaffolding code in the file. Now we're not using the REPL as much anymore. So there's trade-offs. Okay, and now I wanted to demonstrate how I do this in bpython, and this is a video file that's not there. So, that's great. So a very quick live code. I've already let that wall fall, though. We're already doing some live coding. So what I will do often is I'll just say something like from git graph, import load repo, print lines. This is that file that I have over here. It does some git graph stuff. Then maybe over here, I'm going to try, what is it, r equals this load repo. Let's try printing the lines of it. Cool, looks neat. I can, in bpython, hit function, this is F6 is the hard reload. F5 is auto reloading, where we're going to watch the files that have been imported, except standard library ones. So you want to be careful. Well, that's fine, it'll watch them. And then we can go in here and change something about it. So like, what if we didn't print the little merge things? Whoops. So when I save this, it will rerun over here, and it looks like there weren't merges before. So there are merges again. Maybe we could change the way that this thing works and not actually print the entries. I guess that was the dividing ones. We could stop doing this one and rerun this code. Now it goes off the screen. So I will do this F5 auto-reloading thing, and it keeps us in that consistent state because we're just rerunning this each time one of those files is modified. But again, that could take some time. Maybe you're going to like save this file, and it's going to take some time to rerun. So there are issues with that, but that is a setup I will use for testing even several modules because it's watching all of them when any of them change, even something that was imported inside of this file. That will be all right. Great, and that's it, except now I get to pontificate about why REPLs again. So they're really exciting, right? Playing with your live objects is great. You feel like you have these superpowers. I think there's joy in this flow. There's joy in like, oh, this is my universe I have created, and I can walk among these objects. I can see the world that I have godlike created. I think it's fun to use a library without looking at the code and without looking at the docs. It's not a great idea, but it's fun to just play with something. Your friend wrote some code, you import it, and you say, oh, I figured out how it works. Before you use it in a file, you should find out what the return type of that thing usually is or is guaranteed to be. But just one, an n of 1 is useful for our brains for starting to build a mental model of how something works. Other note, these are my thoughts that I've had on a plane for things like how important this is. We mentioned building these universes and walking among them. There's this kind of, I think ephemeral programming is okay. Usually we're programming in order to build up scripts that like, all right, this thing is going to process this data, this is going to build these responses to HTTP requests, this is a product that does a thing. But also neat is ephemeral programming that I just did just now, and it got me, maybe it's knowledge-based. Maybe it's, I wanted to know the answer to the sum of these two numbers. And that's kind of programming you're doing. You're not going to save it to a file. And time you spend in the REPL is sort of building this skill. Instead of building these scripts, you're building your own ability to find out how things work. You're building your ability in Python. I think it's kind of fun. So that's it. Thanks. I guess we've got a few more minutes for any other questions. I'd love to talk about bpython more. I can talk about that all day. Anybody? Oh, great.
Is there any kind of library, as far as you're aware of, where you can run a script that you've saved to a file, and then when you get to a certain line, drop into a REPL? I know that like my current trick for using that is I have a one-line import pdb.setTrace, and it will drop into the debugger. But like you said, sometimes it's easier to work with the REPL rather than the debugger. I was wondering if you could basically just set a breakpoint in your code to drop in there.
Yeah, so code.interact will do that. But then you're stuck with the one I'm encouraging you not to use, the default interpreter. So bpython and IPython, these things also have, you can import that library, and usually it's called embed. So I think for its import from IPython, import embed or something, and then embed open close paren. We'll run that. this interact thing will kind of work here. Now I can jump into my, I wonder where we even are. It puts us in a namespace right here, but you can pass interact, what is it? I thought we got to put in some local variables or something. I guess that's the last one, banner. I could be confused here. So usually the fancy REPLs will come with something like this. There's IPython.embed, and that's great for jumping right in. But yeah, as you say, you can do PDB, and from PDB you get to a shell. Yeah.
For what it's worth, I've actually had that problem, and I've got a code file on GitHub somewhere. I don't know, tweet it or something, PyOhio, that will select the most feature-rich function, or most feature-rich REPL that you have available, and it'll automatically launch that one. There's some weird differences between IPython and the regular Python REPL in how your changes to variables in local state will be reflected once you exit out of it. But as long as you don't reassign variables and do too much modification, you're just looking around, it'll be pretty uniform and work as you expect. So I can tweet a link out to that if you'd like.
Do you have, could you just recite that in a few seconds? I don't mean to put you on the spot, but just if it's.
The code?
Yeah, the code.
Or do you want the link or the?
I guess the link.
Oh, okay. Well, it's embedded in a completely unrelated library.
Got it.
so-
Okay, well, we'll let you figure
Yeah.
it out. And then
I'll
do it.
just,
Okay,
I'll tweet it out. Maybe I'll put
Cool.
it in a gist to be easier.
great. Thanks.
I'll put it PyOhio hashtag.
Cool. Anything else? Cool. Thanks so much. Very fun.